Having gone through the topic list to be learned for amateur radio examination ASOC in India, we will start refreshing our memories by revising mostly what we learned at school. Please note that this is for the pleasure of learning and not an official training program. We often call ourselves as lifelong learners. Electronics uses active and passive components to control the movement of electrons. Electrons are tiny subatomic particles seen in all matter outside the nucleus of atoms. Continuous movement of electrons in a material constitutes an electric current. When there is no continuous movement of electrons, but there is an excess or deficit of electrons in a material causing it to be electrically charged, we call it static electricity. Materials with free valence electrons in outer shells act as conductors, while those without free valence electrons are insulators, which do not conduct electricity. In general, metals like copper, aluminum, and silver are good conductors of electricity, while ceramic and plastic do not conduct electricity well and act as insulators. Though an electric current is due to flow of electrons, by convention it is considered to flow from the positive pole of the battery to the negative pole as shown in the animation. Actual flow of electrons in the circuit will be in the opposite direction. The current flowing through a circuit is measured in amperes or milliamperes. Potential difference across the poles of a battery or across a device is measured in volts. The potential difference across the terminals of a power supply is known as its voltage. The force which causes movement of electrons producing an electric current is known as electromotive force. Passive devices are electronic components like resistors, inductors, transformers, and capacitors. They do not alter the waveform of an alternating current applied to them and hence cannot be used to amplify or rectify currents. Active devices are vacuum tubes, semiconductor diodes, and transistors, or a combination of active devices and passive devices like integrated circuits. They can change the waveform of an alternating current applied to them and hence can be used for amplification and rectification. Rectification is the process of converting alternating current to direct current flowing only in one direction, while alternating currents change direction with a periodicity. Resistors are passive electronic devices which resist the flow of currents through them. Resistance is measured in ohms and sometimes mentioned in higher units like kilo ohms, meaning 1000 ohms, and mega ohms, meaning 1 million ohms. Resistors can be used to limit current in a circuit, as while using a resistor to avoid excessive flow of current through a light emitting diode or LED. They can also be used to provide a voltage using a voltage divider circuit of 2 or more resistors, as in case of providing a bias for the base terminal of a transistor. Transistors are semiconductor devices with base emitter and collector terminals widely used in electronic circuits. Two important types of resistors are wire-wound resistors and carbon resistors. The resistors illustrated earlier are carbon film resistors, the resistance value of which depend on the amount of carbon present in them. Wire-wound resistors can be made of nichrome wire and usually have higher power rating. Variable wire-wound resistors have been conventionally used in rheostats, which are variable resistors with a sliding contact. Variable resistors are also called potentiometers. They have three terminals unlike the usual resistors which have only two terminals. Central terminal provides the variable resistance with respect to the other terminals. Potentiometers can have a turning knob to alter the resistance value in the circuit and are widely used as volume controls in radios and amplifiers. A preset potentiometer is one in which the resistance value can be changed using a screw-like mechanism and set at the value until it is altered later if needed. Power dissipation capacity of the resistor usually depends on its physical size and can be rated at 0.25 watt, 0.5 watt, 1 watt, etc. Now I am demonstrating the change of resistance, continuous change, as the potentiometer screw is being turned. Just like tuning a radio. The value of the resistor is indicated on the resistor with a color code. The resistors shown here have a 4-band color code, which is the most common one in use. First two bands indicate the resistance value, which has to be multiplied by the code on the third band. Fourth band indicates the tolerance. All the resistors shown here have a golden band for the tolerance, indicating 5% variation above or below the coded value. If there is no tolerance band, the tolerance is presumed to be 20%. Color code values are as follows: black 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, grey 8, white 9. Golden color is for 5% tolerance, while silver color is for 10% tolerance. As mentioned above, if there is no tolerance band, it implies 20% tolerance. Third band is used as a multiplier for the first two bands. Multiplication is by 10 to the power of the third band color code. Multiply by 1 if it is black, by 10 if it is brown, and by 100 if it is red, etc. This is a symbol of a resistor used in circuits and indicated by the letter R. Resistors can be connected in parallel or series. When the resistors are connected in series, the total value is the sum of the individual values. When they are connected in parallel, it is a complex calculation as shown here. Checking the total value of resistors connected in series is rather simple. You just have to add the total values of each resistor and you get the final value. But it is not that simple when you connect resistors in parallel. You have to take the inverse value of each resistor, sum them up, and finally get the inverse of the sum to get the final value of resistors connected in parallel. To simplify things in the demo, we will take three 10K resistors. 10K resistor has a brown band in the beginning representing a color code of 1, followed by a black band representing 0, and then an orange band representing the multiplier of 1000 or 10 to the power of 3. So the value will be 10 into 1000 is equal to 10,000 or 10 kilo ohms. Single 10K resistor on breadboard measures 9.82K with golden tolerance band of 5%. Selector at 20K position. Three 10K resistors on breadboard measures 29.6K with golden tolerance band of 5%. Selector at 200K position. Two 10K resistors in parallel on breadboard measures 4.91K, about half, with golden tolerance band of 5%. Selector at 20K position. Three 10K resistors on breadboard in parallel measures 3.2K, about 1/3, with golden tolerance band of 5%. Selector at 20K position. Same value of resistors were used for simplifying the calculations so that it is easy to check by mental calculation. If different values are used, it will be more difficult to calculate like that.